To build a physical bridge, the people in charge of the concrete and steel must prove they know exactly what they are doing. Before a single blueprint is approved, professional civil engineers must put their names on the line. They hold formal licenses, they sign off on structural integrity, and if that bridge fails due to their negligence, they face severe personal liability. Yet, as we shift our critical infrastructure from concrete pillars to software, that safety net vanishes. Complex algorithms now seamlessly and invisibly dictate the critical operations of our modern lives. We demand strict legal oversight for the physical infrastructure we drive on, but we require absolutely zero equivalent licensing for the software creators building the systems we live within. Public interest AI is already live and making decisions in high-stakes environments. When a patient steps into a modern medical scanner, AI systems provide diagnostic support today, without an individual licensed engineer signing off on that code. The same goes for algorithms monitoring critical utility grids or running election-adjacent platforms. Right now, Hong Kong statutes mandate exactly zero registration or licensing requirements for individual AI practitioners. Other global legislative bodies are already responding. The EU is deploying the AI Act, and organizations like NIST are defining practitioner-level obligations to stop the dangerous move fast and break things mentality from infecting critical systems. Letting software teams run high-stakes public interest algorithms without individualized professional accountability is an active threat to public safety. To close this accountability gap in Hong Kong, a specific structure is taking shape: the AI Systems Engineer, or ASES, framework. It operates as a two-part solution. The first half is a strict code of practice. This outlines 11 sections of precise ethical guidelines, technical robustness requirements, and risk management standards for anyone building public interest AI. The second half is the registration procedure. This builds the actual profession by setting hard requirements for an engineer's competency, mandating continuous professional development, and defining the specific field experience needed to qualify. Together, these parts take the abstract idea of tech ethics and turn it into enforceable professional rules. It provides the necessary architecture to actually protect the public. This diagram illustrates a 4-tier risk classification system. Because a customer service bot doesn't need the same regulatory scrutiny as a power grid monitor, oversight operates on a sliding scale. At the bottom, Tier 4 and Tier 3 cover minimal to moderate impact tools, like internal productivity software or research prototypes. These can be overseen by entry-level graduate AI engineers. Move up to Tier 2, and the stakes increase to high-impact public interest tools, like credit scoring systems. Projects at this level require a registered AISE with over 3 years of vetted public interest experience. At the peak is Tier 1, critical safety. Life or death systems require a senior or chartered AISE who has spent over 8 years leading high-risk projects. This specific risk matching protocol adapts the EU AI Act's established risk tiering approach and maps it directly to Hong Kong's existing sector rules. By matching the level of human expertise to the level of algorithmic risk, the framework ensures safety in dangerous environments without suffocating low-risk innovation. Earning a registered or senior AISE title demands specific proof of technical and ethical judgment that standard coding tests often miss. Applicants must prove mastery across 4 specific domains: machine learning theory, strict data governance, fail-safe design, and privacy compliance. They have to know how to build a model and exactly how to stop it if things go wrong. Once registered, these engineers face strict operational mandates. For instance, if an active system breaches safety protocols, the engineer is bound to a mandatory 72-hour incident reporting window. These requirements guarantee that registered AI engineers possess the technical capability to build complex algorithms and the ethical duty to prioritize human safety above all else. You might wonder if forcing a strict licensing process onto a fast-moving technology sector is a bureaucratic impossibility. We have historical proof that it works. During Hong Kong's rapid urban expansion, the Hong Kong Institution of Engineers operated purely as a voluntary body for decades before it ever achieved statutory recognition. The AISE Code of Practice is doing exactly the same thing. By building a voluntary registry now, it starts that identical historical clock for the digital engineering profession. Professionalizing a disruptive field is a proven historical process that we must now repeat to ensure public safety. This animated timeline lays out the specific 4-stage roadmap. Step 1 is happening right now, establishing voluntary registration, governed by published competency and disciplinary standards. From there, the framework expands. Stage 2 secures formal endorsement from government regulators, followed by Stage 3, which builds reciprocal recognition with international tech organizations. The ultimate destination is Stage 4, achieving formal statutory recognition. This means a legal licensing regime analogous to the laws governing civil and structural engineers today. Right now, tech accountability is buried behind the opaque walls of faceless corporations. This roadmap creates a future where the burden of safety rests on individually accountable, licensed professionals. We legally bar uncertified engineers from building the physical infrastructure of our cities. We must demand the exact same rigorous accountability for those building our digital future.